Alright guys, just had to make a second video here. Coming back to you guys with this. Notice that I just broke it up into some rectangles. Maybe your rectangles look a little bit different, but the important thing is, did we get 54 centimeters squared? If we did, perfect. Alright, perimeter, again, I kind of labeled it all the way around. Notice I did, even though I kind of sectioned off some of the rectangles here, I did keep that bottom as 9. That was really helpful. Just counting around. Here's even though it's 9, it's really 3 group of 3s. 3, 6, 9. So that's 3 3s. There's a 4th, 5th, 6th, 7th, 8th, 9th 3. And again, 3 more 3s. So that's just 12 3s. 3 times 12 is 36. All right. Now, when we're looking at this here, sometimes we have a shaded region, and we just want to be able to find the area of just what's inside. For example, maybe we have a patio here. All right, we're just trying to find the area of this. We have a patio. We have a fire pit, very nice fire pit, looking there in the inside, but we just want to lay some concrete around. And so, you know, as a construction worker or whatever, you need to be able to synthesize and take two shapes together and subtract them, right? We would subtract the areas in order to take out that missing part, right? So, a lot of ways that we could write this. We know that we're going to take the area minus the area here, area of big rectangle, and then minus the area of the small rectangle. Alright, so it looks like here the big area, or the big rectangle, just has an area of 8 times 12. Right, 8 times 12 there. So 8 times 10 is 80, and then I would have to add 8 times 2 to that, so 80 plus 16 is just 96 inches squared. And again, we said that we're going to subtract the smaller one. The smaller one, pretty straightforward, just 4 times 4. We'd have to subtract 16 inches squared. So for my total area, again, just subtracting there, just subtracting, it would be 80 inches squared. Alright, we could do the same thing here, even with a circle. Alright, now here's what we want to do. This is where the exact terms of pi really is helpful. Okay, so we're going to write both answers of these circles here in exact terms. Alright, if we can't see it, just as asking for this shaded region there. What's the area of that? Donut, yummy. Alright, let's see if we get a different color here. Alright, so we're going to have the area of the big circle minus the area of the smaller circle. Alright, so again, the area, we have to be reminded the area is just pi times r squared. So area equals pi times r squared. I'm going to leave it in exact terms of pi, so I'm not going to multiply this at least yet by 3.14. So here we go. For the big circle, it looks like the radius is only 60 millimeters, right? The whole thing is 120. So pi times 60 squared, or area equals 3,600 pi. Alright, so that's my area for my bigger one. For the smaller one, same thing. 50 is my diameter. So area equals pi times 25 squared. Again, we're just looking at half of the diameter. 25 times 25. That's 625. Just one of those multiplication facts that I memorized over the course of time. And so again, I guess I should have switched that. We'll just kind of do this right here. Alright, so we're going to subtract these areas. Now, what this pi does is this pi almost acts like a variable in the fact that these are like terms. So I could just subtract the numbers in front. Right? So we have 3,600 and 625. And just subtracting them, let's verify this here, just getting some borrowing out of the way when I subtract, would be 2,975 pi. That would be the exact answer. Alright, now again, it's millimeters, so millimeters squared. If it did ask for an approximate value, again, we would just have to take that number and multiply by 3.14, or 22 sevenths. So my approximate value there is 9,341.5 millimeters squared. Okay, so it's really helpful sometimes to leave it in the pi form, especially if we know that we're going to be doing some subtracting with those numbers. It just kind of takes out all of those decimals with it. All right, and then we're only multiplying by pi once as opposed to doing it twice and then doing more operations with it. All right, last couple things here. One thing I want to see is being familiar with what a triangle or any shape really there looks like on the graph. So we're looking for the perimeter of this shape, perimeter here. All right, so when we're looking at the perimeter, let's do green. We haven't done green here. Perimeter, we know that we just have to add up all sides, add all sides. All right, so it looks like we have a side here in red. Again, one thing that we could do is just count the distances because it's on the coordinate plane. If you want to, you could use the distance formula or the Pythagorean theorem. All right, so it looks like here it's -3 to +3. That would just be 6. So for the base is 6 right there. Let's say that we have the height here. The height, again, that's from 6 to -2, so that's just 8. So the height is 8, and again, we're just adding those together. This is the tricky one right here. Okay, remember a couple ways that we could think about this. We could think about it using the Pythagorean theorem, right? So that would just be 6 squared plus 8 squared. Again, that's a squared plus b squared equals c squared equals c squared. So 36 plus 64. 36 plus 64. That's 100. Or, we're going to put it under the square root, obviously. And so that means that this right here is just 10. Wow, a lot of work for a nice number. Super duper. Alright, so that means my hypotenuse would just be 10, right? Add them up. 6 and 4 is 14. 14 and 10 is just 24, right? Now, it is on the graph, so we're not sure of the label. Anytime we're not sure of the label and it doesn't give it to us, we could just use the phrase units, okay? Again, we could use that distance formula for those instead of the Pythagorean theorem. Okay, just to recall, the distance formula is the quantity under the square root of x1 minus x2 squared plus the quantity of y1 minus y2 squared. All right, and I think it's easy, especially when we have straight distances like horizontal or vertical here, just to count it on the graph. But if you feel comfortable plugging those in, right? Remember, we could have just used x1 as this for the 3, and this is for the hypotenuse here. 3 minus -3 squared. That would just be 6 squared, which is what we had right here. For the y values, it would be 6 minus -2 squared, or just 8 squared. Right? So there's my 6 and my 8 squared. There's my 36 and my 64, or just 100, excuse me, the square root of 100, or just 10, right? So we get 10 either way. Okay? So that's what we're looking at here using that information. All right? A couple more things to look at. It says find the area of a square with a perimeter of 10. Okay? So again, maybe a sketch is helpful here. I need to find the area of a square when my perimeter is 10 inches, or excuse me, 10 in inches is what it said. 10 in inches. All right? So that means we're just dividing it by 4. So this is going to be 5n over 2, 5n over 2, and 5n over 2, right? I'm just taking 10 in, divide it by 4. That means that each side is 5n over 2. 5n over 2. Now, if I'm finding the area now, I know that we're just taking two sides and multiplying it together. So 5n over 2 times 5n over 2. And that is just 25n squared over 4, right? Inches squared. Right, so that n is just acting kind of like a variable here. All right. Again, some more with just letters. We're finding the area of a triangle. Area of a triangle is just the 1/2 of the base times the height. So we established that this right here is the base, where this is the height. And so I just have it equal to 1/2 of the base, 5x minus 2y, times the height of 4x plus 3y. And if we recall, we are just using that double distribution right here, right? A couple things that we could do. I would always try to multiply that fraction in last, so I'm going to go ahead and just make sure that I have every single option of multiplication multiplied there. And so what I have is 25x squared. That's going to be 15xy, so 15xy minus 8xy. Again, multiply the numbers and just stick the letters behind it. Minus 6y squared. All right, looks like we can combine some things here. All right, we have some like terms in the middle. That would just make it 7xy. That would just make it 7xy there. Minus 6y squared and 25x squared. Right, it's positive 7y. Well, we still have that 1/2 right here. So again, we just would distribute that, reducing everything that we can. Again, this is a good problem to finish out on. 25 divided by 2, or just 25 halves, x squared. A half times 7, so it would just be 7 halves xy. And then here's one that finally does reduce, negative 3y squared. All right, so really weird way to have in terms of area. Again, that's feet squared, because that's what we were measuring that in. Feet squared there at the beginning of the problem. Okay, but that is the final answer right there. All right, so thanks for watching these videos. Again, fill out these notes and take a look at the newest MathXL assignment, all about perimeter and area.